So let's continue with some information about carbons in general. We know that if it's fully saturated, it's called an alkane, and it just contains carbons and hydrogens. So if I draw this out, you can see that this has got 1, 2, 3, 4, 5 carbons. Whereas if I draw this out, it's got 4 carbons. If I draw this out, it's got 3 carbons. And you're going to say, well, how do we know what the names of these are? Well, I can tell you that this is propane. Okay. If it's got 2 carbons, it's called ethane. If it's got 1 carbon, it's called methane. Okay, and the formula is going to be CH4 and C2H6, and this is C3H8. If you're not convinced of that, let's just check. 1, 2, 3, 4, 5, 6, 7, 8. Ta-da! Propane. Now, we move on a little further. For C, this is butane, and all of these are gases. So this is C4H10. And if you're paying close attention on this side now, you'll notice that the general formula for alkanes is CnH2n plus 2. After butane comes pentane, and that's a relief, because after pentane, we can now use the Greek prefix to indicate what the name of the alkane is. So if it's got 6 carbons, which is going to look like this, 1, 2, 3, 4, 5, 6, this is hexane. And as you'd expect, 1, 2, 3, 4, 5, 6, 7 is going to be heptane. And the suffix is A-N-E because they're all alkanes over here. And it's hept because there are 7. So with the Greek prefix continue, we've got oct and non and dec. And we'll just slide in undec and dodec to say 8, 9, 10, 11, and 12. Okay, so we've got a dozen of them. Okay, so we need to recognize that. And then just to not complicate things, I'm not trying to complicate things, I want you to see how this begins to extend itself. Okay, if this is an alkane, I'm going to introduce to you something that has a double bond, and this is alkene. And if we have a triple bond, this is an alkyne. You can see all of those, right? So this is an alkane, suffix A-N-E, suffix E-N-E, suffix Y-N-E, because it takes our alkynes to do reactions in chemistry. 1, 2, 3, 4, 5, this is pentane. 1, 2, 3, 4, 5, this is pentene. You guessed it, 1, 2, 3, 4, 5. Remember that in case you missed. This is pentyne. So you can see that knowing the common prefix and recognizing the name will help you identify all of the functional groups that we're about to see and how we name them all. But that's just sort of a benefit there. And let me give you an example here. Put these down here. This is 1, 2, 3, 4, 5, 6, 7. And this is 1, 2, 3, 4, 5, 6, 7. They're both 7 carbons, so they both have the prefix hept. But this is heptene, and this is 2-heptene. And hopefully you recognize that the reason this is 2-heptene is the double bond begins at carbon 2. Whereas here this is heptene, and we don't put a number there because it begins at carbon 1. Subtle, but very important. And then we look at the formulas of alkenes, there's CnH2n. We've got 7, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we've got 7 carbons, we have 14 hydrogens. We lose 2 hydrogens as we go from alkanes to alkenes. So that's just another brief comment on alkanes and groups. Next lecture, will be on functional groups.